Hello, welcome to the lesson on geometric random variable. I hope that you have downloaded the soft copy of the lesson so that you can follow along. Let's consider a simple example. The probability that Jane hits a target when she shoots an arrow is given by P. And the probability that she misses is given by Q equals to 1 minus P. What is the probability that she hits a target in her first attempt? Okay, let X be the random variable representing number of attempts including the successful attempt. So in this first example, Px equal to 1 is simply P. What is the probability that she is successful in the second attempt? So Px equal to 2 will be equal to the probability of failure in the first attempt and a success in the second attempt. So the answer is simply QP. And what is the probability that she hits the target only in the third attempt? So we have Px equal to 3 equal to Q times Q times P equal to Q squared P. So as you can see, we have Px equal to 1 equals to P. X equal to 2 equals to QP. Px equal to 3 equals to Q squared P, and so on. So in general, Px equals to x here, small value of x here is equals to Q. As you can see, the power of Q is always 1 less than the value of x. So it should be Q x minus 1 times P, which gives us the probability density function of the geometric distribution for values of x equals to 1, 2, 3, and so on. Moving on to the next page, let's look at another example. The probability that a driver passes the written test for a driver's license is 0.55. What is the probability that a person will fail the test on the first try and pass the test on the second try? So Px equal to 2 will be equals to 0.45. That's the probability that he fails, and then followed by 0.55. Okay, we bring up our Ti Nspire and we will try to work out the answer. So we have 0.45 times 0.55, and the answer is 0.2475. Or we can also use the inbuilt function. You click probability distributions and find geometric PDF. You can key in the value of P, 0.55, and the value of X, which is 2, and we will get the same answer, which is 0.2475. So if you do part B now, what is the probability that a person will only pass the test before the 5th try? So we have, if you look at the calculator, we want P x less than 5, and that is the same as P x less than equals to 4, and you can see that the answer from the calculator is 0.958994, approximately 0.959, giving your answer to 3 significant figures. Okay, let's look at the cumulative distribution function of a geometric random variable. So we have CDF fx will be equals to px less than or equal to x by definition of a CDF, and it is equal to sum of q x minus 1 times p, where x starts from 1 to the value of x that you want. And this is the same as the product of p and the series 1 plus q squared and so on up to plus qx minus 1. I think we recognize this series as a GP, sum to x terms, and that works out to a 1 minus q to the power of x over 1 minus q, which equals to 1 minus qx, since p is equal to 1 minus q. Or we can also use this expression if we wish. Now let us look at the mode, mean and variance of a geometric random variable. We will start with finding the mode. Let us turn to our graphic calculator again. So let's start by adding a spreadsheet, and what we want to do is to create a sequence of numbers. So we type in SEQ followed by x, comma 1 to 50. And then we press enter. It will generate a sequence of numbers from 1 to 50. Next, we will generate the probabilities associated with the values of x. So we go to distribution and go back to geometric PDF. We put in the value of p, which is 0.3 in this example. And the value of x, we will just give the column reference to A, and we say OK, and all the probabilities have been generated. The next thing we will do is to name our values. So for the x values, we will simply call it xval. And for the probability values, we will call them y-val. And there you have it. What we want to do now is to insert another document which is essentially a scatter plot of the data. So we will ask for data and statistics. You see a lot of random numbers there. What we do is to arrange them. So what you do is that for the y-axis you choose y-val, and the x-axis you choose the x-val. And then you see the geometric distribution, and probably you can guess now where it gets its name from. And we choose analyze the graph there, so that we can find out the mode. And the mode is clearly 1, because that gives you the highest probability. As you can see, the probability when x equals to 1 is p. The probability when x equals to 2 equals to qp, and probability that x equals to 3 will be q squared p, and so on. You can see that the probability is getting smaller and smaller, and therefore the highest probability is always p. Is always p, since q x minus 1 times p is always much smaller than p, for all x greater than 1. So this means that the mode of a geometric is always, and I underline that, x equal to 1. Okay, now we will just have a quick run through of how to find the mean and variance of the geometric distribution. You are not required to prove this. So I guess this will be good for people who want to know how the formula for mean and variance come about. Okay, we start the same way as we would do in order to find the mean of a random variable, which is essentially ex equals to sum of x px. That's how we start. As you can see, we have qx minus 1p, the distribution for geometric, and we find that we actually have a series here. What I did is that I know that the series is nothing more than the differentiation of another series with respect to q. And we know that this series here is a geometric series, geometric sum to infinity. Alright, and that's the result here using the formula for s infinity to a over 1 minus r. And you differentiate it. This is the quotient rule. And we get the answer, which is just 1 over p. So the mean of a geometric distribution is given by ex equals to 1 over p. Now finding the variance is a little more complicated. Consider the following series. Multiplying both sides by q you will get q squared plus 2q cubed plus 3q4 plus 4q5 and so on. Subtracting 2 from 1, we will get q plus q squared plus q cubed plus q4 plus q5. This is a sum to infinity of a geometric series with r equals to q. And the first term is equals to q. So the sum to infinity is equals to a over 1 minus r. And in this case, it will be q over 1 minus q, as you can see on the right hand side over here. We also factorize out 1 minus q on the left, as you can see. And we have the sum of xq to the power of x from x equals to 1 to infinity being q divided by 1 minus q squared. Now we are ready to find variance of x. We consider the expectation of x squared, and this is the formula, which is essentially sum of x squared px. And we can factorize out the p over here. And we observe that if we differentiate with respect to q, we will get x squared q x minus 1, as you can see over here. And since the sum of xqx has been found and is equal to q divided by 1 minus q squared, as you can see over here, we can use this result to find the variance of x. And applying quotient rule of differentiation and factorizing, as you can see, we can find the expectation of x squared to be equal to 1 plus q divided by p squared. So we know that the variance of x is given by e of x squared minus e x squared, and therefore we can use the result before, 1 plus q divided by p squared minus the mean, which is just 1 over p, and square that, and we get the answer for variance, which is q divided by p squared. Therefore, we have the variance of a geometric distribution to be q divided by p squared. So let us summarize today's lesson on geometric distribution. First of all, the PDF for geometric is equals to q to the power of x minus 1 times p, where x equals to 1, 2, 3, and so on. Secondly, we have found that the mode of x being a geometric distribution with probability of success p is always equals to x equals to 1. Thirdly, the mean of a geometric is equals to 1 divided by p. And lastly, the variance of x is equals to q divided by p squared. Let's finish off this lesson with a simple example. An experiment consists of a fair die thrown twice consecutively. A success occurs when the total sum of the numbers shown on the face of the die is prime. Let x be the number of experiments conducted to achieve the first success. Find the probability of success. So we have to add the two dice. So we have 1 plus 1 equals to 2, 3, 4, 5, 6 and 7. And on the second row here you have 3, 4, 5, 6, 7 and 8. On the third row you have 4, 5, 6, 7, 8 and 9 and so on. Let me just fill the rest. Now we will look at which sum will be prime. So as you can see, 2 is prime, 3 is prime, 5 is prime, 7 is prime, and we have 11, which is also prime. The total number of prime is 15 of them. So the probability of success is equals to 15 divided by 36, which is 5 over 12. Okay, x has a geometric distribution with probability of success 5 over 12. So we are asked to find the mean and variance. So Ex is equals to 1 over P. So that will be 1 divided by 5 over 12. And what would that be? Let's just bring out the calculator now. Okay, let's get the answers for both the mean and variance. So the answer is just 12 over 5. Which is 2.4. You want to put it in decimal. And the variance will be equals to Q over P squared, which is equal to 1 minus P, which is 5 over 12 divided by 5 over 12 squared, and that is equal to, just use the calculator here, okay, here it is. Let me just work it out. And the answer is 3.36. There you go. This is how we find the mean and variance of a geometric distribution. Now we have come to the end of the segment on geometric distribution. There's a little quiz to help you revise. Feel free to look through this video again if you have any doubts. Good luck!